Hello everyone, welcome to my channel. In this video we are going to discuss about one of the application of the stack, that is the expression evaluation and expression conversion. So first we will see how can we evaluate an expression. So an expression is a collection of operators and operands that represents a specific value, right? So an expression is nothing but a collection of operators and operands. So operator means any arithmetic or logical operations like plus, minus, multiplication, division, greater than or equals to, so like that. So it may be any arithmetic, logical or relation operator. And operand means any numerical value, that is called as a operand, that represents a specific value. So here if you are applying the operators on operands, it will give some specific value. Operator is a symbol which performs a particular task like arithmetic operation or logical operation or conditional operation, right? So it may be addition, subtraction, multiplication, division, greater than or equals to, less than or equals to, it is a conditional operator. And logical operation like and, or, not. So like that we can perform any kind of operation by using the operator. So operator is nothing but a symbol, and operands are the values on which the operators can perform the particular task. So here operand can be a direct value or variable or address of particular memory location. So here operand may be any direct value or it may be any memory location. It may refer to any memory location. So now we will see how can we evaluate an expression. So before going to evaluate an expression, so first we will learn about the operators here. Okay, that is the operator precedence. Suppose in a given expression like this, a plus b into c. So this is a particular expression. So if you solve this expression, it will give some value, right? But in the given expression, there are more than one operator. Okay, so in this type of case, so how can we calculate this? How can we evaluate this expression means based on the priority of the operator. So here, normally the multiplication and division operation will be having more priority than the addition operation. So first the multiplication operation will be done, then the result will be summed with the a. Okay, so here the multiplication is having the higher priority than the addition operation. So here the table is given based for the precedence of the operators. Okay, so here the logical NOT is having highest priority, parenthesis, modulus, division and multiplication are having higher priority than the addition and subtraction. And the relation operators like greater than equals to, less than equals to, not equals to. So this represents the priority. So logical NOT is having the highest priority and equals to is having the lowest priority. Okay. So another thing is the precedence and associativity. Associativity means we are going to use this associativity whenever there are in a given expression there are more than one operator of the same priority. Suppose in the given expression 2 plus 3 plus 5. Okay, so if here two operators of same priority are used, then how can we evaluate this operator this expression means based using the associativity. Associativity means, so here for the addition and subtraction the associativity is left to right. So we are going to start from the evaluate starting from the left to right. So first we will solve 2 plus 3, that is 5, and then 5 plus 5 is 10. So the answer will be 10, right? So like this we will solve the particular expression, okay, with the same priority operators using the associativity. So I will give a link below briefly about the operator precedence and associativity. So we will see the expression types here. So based on the operator position, expressions are divided into three types, that is infix, postfix and prefix. So what is the infix expression? So in the infix expression, operator is used in between the two operands. So here the A is an operand, B is an operand, and plus is the operator. So using the operator between the two operands. Similarly, the postfix expression. So here we can say that operator follows the operands. That means, so postfix, that means after the operands there is a operator. Okay. So it is also called as a reverse Polish notation. Postfix is also called as reverse Polish notation. So next one is prefix expression. That means prefix. That means the operator comes before the starting of the expression, right? So in prefix expression, operator is used before the operands. You can say that operands follow the operator. Okay. So the operands will follow the operator. So it is called as the Polish notation. So now we will see different types of conversions from the infix to for the infix, prefix and postfix. So first of all, we will see how can we convert the infix to postfix conversion. Okay. So here there is an application of the stack. That means we are going to convert the given statement which is an infix to postfix using a stack. Okay. So for this we are going to take a stack and then we are going to insert the elements starting from left to right. So first, before going to convert the infix to postfix, so we will know about the rules. So no two operators of same priority can be placed in a stack. Okay, so two operators of same priority cannot stay together in a stack, and low priority operator cannot be placed on a higher priority operator. So this is also one of the properties. So we have to follow these two properties. Okay, so two operators of same priority cannot stay together in a stack, and low priority operator cannot be placed on higher priority operator. So first we will insert starting from the left to right. So first we will insert the symbols. So we will push the symbols only to the stack, and the expression will be written separately here. Okay. So first braces is inserted here into the stack. So first we will push the parentheses to the stack. So parentheses will be pushed to the stack, and then next one is A. So we will write the A here. So next plus is pushed to the stack, and then B. Okay. So after that one, division operation. Okay. So we have to push the division operator onto the stack. So division operation, and then C. Okay. So next we have to push the multiplication operation here. Okay. So we cannot. So we have the rule that no two operators of the same priority can be placed in a stack. So here the multiplication and division operation are having the same priority. So we have to pop the division operation. Okay, so we have to pop the division operation from the stack, and we have to insert the multiplication operator to the stack. Okay, so we are popping the element from the stack and writing it over here, division operator, and then we have to push the. So now we have to push the multiplication operator into the stack. Okay, so next we are going to insert the open parenthesis here. Then we will insert the. So we are going to write the D value here, D, and then again push the operator plus. Okay, plus here. Next write the value E here, and then we are going to push the parenthesis here. So since there is one open parenthesis and the closed parenthesis, that means we can remove the element addition from the stack. We can pop it out from the stack, and we will write it here. Okay, so we will pop the element plus, because we are having one open and closed parenthesis here. So now we can remove this thing from the stack. Okay, E plus. So now we have to insert the minus. Okay, and then F, and then close it parenthesis here. So we are going to so we have to insert the minus operator here, but we are again having the problem, that is low priority operator cannot be placed over the higher priority operator. So minus is having the low priority than the higher priority, that is the multiplication operator. So for this, so first of all we have to pop out the multiplication operator out, and then we can insert the minus operator here, okay. So we have to first pop it out, that is the multiplication operator, and then we can push the minus operator here, right? So we have to pop the multiplication operator and insert the minus operator, okay. So now also again we are having the same problem, that is plus and minus are having the same priority, okay. So plus and minus are having the same priority, so that's why we cannot place the minus over the addition operator. So now, so what we will do, so first we will pop out the addition operator, okay. So we will pop the addition operator out of the stack, and then we will insert the minus operator into the stack. So now we will insert the minus operator into the stack. So now there is no issue here. So now next we will insert the F, okay. So after the insertion of the minus into the stack, now we will go to the next one is F, and then so we are going to so plus star plus and F. So after this we are getting the minus value, okay. So now after the F there is a closed parenthesis, that is closed parenthesis we are having. So now we are having the open and closed parenthesis here, so we can remove the minus from the stack. So now we will get the minus operator here out of the stack. So this is the postfix conversion of the stack, okay. Okay, so in this manner we can convert the infix to postfix conversion. So next one is the postfix to infix conversion. So in this type of conversion, so we are going to convert the given postfix expression to the infix notation. So this is the postfix expression that we want to evaluate now, okay. So for this we are going to consider a simple formula, that is the operator 2 and operator. So this is the operand 2, operator and operand 1. So in this manner we have to write the given notation, okay. So first we will insert the element A to the stack, next we will insert the value B to the stack, and then we will insert the value C into the stack. The rules for the conversion will be same, that is the no two operators of same priority can be in a stack together, and low priority operator cannot be placed on a higher priority operator. So next minus will be inserted here, okay. So now one operator is available in the stack, so now we will go with this formula, operator here operand 2, operand 1 and operator, okay. So this is the operand 1 and operand 2, okay. So here operand 1 and operand 2 are available now, that is operand 1 is C, okay, 1 is C and 2 is B, okay. So now we are going to pop this, we are going to pop the element from out of the stack, that is B minus C, right, operand 2, operator and operand 1. So B minus C will be popped out of the stack, okay. So B minus is popped of the stack, and we are going to remove the elements here on the stack. Again we are going to push this same element to the stack, okay. So B minus C is pushed into the stack, okay. So now we will go with the next one. So next is the next operator is plus, okay. So now plus is available here, So plus is available here, so plus is inserted into the stack. So now again the operator is available here. So operand 1, operand 1, operand 2 are available here. So operand 2 plus operand 1, that is the b minus c. So a plus b minus c. Sorry, b minus c. So a plus b minus c is there. So we are going to again push it back to the stack by popping the elements completely here. Okay, so that is the a plus b minus c. So this is the element. Okay, so now next we will go with the next element, that is d, and then e, next minus. So again the operator minus is available here. So now we will follow the same rule, that is operand 2, operator and operand 1. Okay, so operand 2, operator and operand 1. So now we will pop this element out, that is d minus e. So we are going to pop the d minus e out of the stack, and again we will going to push it into the stack. So now we will pop this element out of the stack. Okay, so here it will be like d minus e. Okay, so next one is f. So again we will push the g, and the next one is the minus. So we are going to push the minus operator into the stack. Okay, since the operator is available, we are again going to apply this formula. So the expression will be f minus g. Okay, so now we are going to push it into the stack. Okay, f minus g will be pushed to the stack. So here f minus g will be pushed into the stack. So next value is h and plus. So again the operator is available. Now we will apply this formula. Okay, that is the f minus g plus h. Okay, f minus g plus h. So now we are going to pop these elements out of the stack and push the f minus g plus h into the stack. So now the next one is the division operator. We are inserting the division operator. So again the operator is available here. We will apply this same formula here. Okay, so now the expression will become d minus e by f minus g plus h, because this is operand 2 and operand 1. Okay, so now it will be like this in the format. Okay, so d minus e by f minus g plus h. So this is the given format. Okay, so next again in the next thing, in the operand 1, so a plus b minus c. So this is the two elements, right? Okay, so again we are going to push the multiplication operator here. That means the operator is available now. So again we will apply the same formula. So now it will become a plus b minus c. Okay, so it will again become so a plus b minus c into d minus e by f minus g plus h. So this is the final answer. So this will be popped out of the stack, and the expression from the postfix to infix is available now. Okay, by using this simple formula we can convert from postfix to infix. So next one is conversion from postfix to prefix. So in this conversion also we are having a simple formula, that is the operator, operate and operand 2 and operand 1. So this is the formula. That is the operator, operand 2 and operand 1. So now we will convert the given expression into prefix format. So first we will insert the a value, and then b, and then c. So now division is inserted, that is pushed to the stack. So now Since the operator is available, so we are going to pop the first two elements. Okay, that is division and DC. Okay, this is the expression popped out of the stack and then again push it to the stack. Okay, so now we will insert division DC. Okay, so next minus is pushed here. Okay, so minus is pushed into the stack. So now the operator is available. Again this expression will become minus operand 2, that is the A by BC. Okay, minus A by BC. So here we are going to pop these elements from the stack and write this minus A by BC. Okay, so next one is the A is pushed to the stack and then K is pushed into the stack. So now next is division operator is pushed to the stack. Okay, so again apply the same formula, that is the operator, and operand 2 is A, operand 1 is K, that is division AK. So we are again going to push it back to the stack. Okay, that is the division AK. Okay, so next we are going to go to the next element, that is the L. Okay, so next is minus, right? So again we have an operator here, so minus operand 2 is by AK and operand 1 is L. Okay, so again push it back into the stack. So we will get the answer here. We will get the expression like this in the format minus division AK L. Okay, so next one is the last one is the multiplication operator. So insert the multiplication operator here. Okay, and so here we are having the operator, operand 2 and operand 1. So the final expression will be in the given format, that is the multiplication operator here, followed by the minus A by BC minus division A K L. So this is the final output of the given postfix to prefix conversion, right? So the expression is in the prefix format. The next one is the conversion of prefix to postfix. So in this also we are having the formula here, simple formula, that is the operand 1, operand 2 and then operator here, right? Operator. So for the conversion of prefix to postfix we have to follow two steps, that is the reversing and solving. So first of all we have to reverse this given expression here, right? Like L K A by minus C B by A minus multiplication. First of all we have to reverse this and then we can insert it and perform the same push and pop operations by applying this formula. Okay, so now we will insert the value, that is first one is the L, then K and then A. So after this one division operation, so we are going to apply the formula operator, operand 1, operator, operand 2 and operator, that is the division. So AK division, so it will be inserted to the stack, AK division. Okay, so next, so we will go to the next one, that is the subtraction operation, minus. Okay, so it will perform the, so we are going to solve this by using the formula. Okay, that will become AK division L minus, right? This is the given formula format. So we are going to pop all the elements from the stack and push it again back to the stack. AK division L minus. Okay. So next one is the C. So we are going to insert the value C and then B into the stack. So after that one, division operation. So here the operator is available, so we'll apply the formula again. That is BC division. Okay, so we're going to pop the elements and perform the we'll arrange the elements in the given format. Again we will push it back to the stack. Okay, so BC division. So next one is A. Insert it into the stack. Next is minus. So we are going to again apply the same formula. That is the A, B, C minus. Okay. So we will apply the formula. That is A, B, C minus. Okay. A, B, C, L minus. So the A, B, C division minus. So next one is the last one is the multiplication operator. So we'll enter the multiplication operator and we'll get the output here like A, B, C division minus AK bar L minus multiplication. So this is the final output of the given expression. So next one is conversion of prefix to infix notation. Okay, so here also we have to reverse the given notation and then solve this expression. So here we are having a formula called operand 1, operator and operand 2. So first we will reverse the given expression here, that is L D A division minus C B division A plus multiplication. Okay, so now we will push the elements here L D A and then division operator. Okay, so operand 1. So operand 1 is A division D. So this expression is evaluated based on the formula, and then again we are going to push it back to the stack. Okay, so push it back into the stack. That is A division D. Okay, so next one is the minus operator. So again we will go with the formula. So after applying the same formula, we will get the answer as A division D minus L. Okay, that is A division D minus L. Okay, so after this given formula, after this one, so next element is C. C is inserted, then B, then division operator. So again we are going to pop the elements here, 3 elements out of the stack, and we will apply this formula. Okay, that is B by C. So after applying this formula, we will get the answer as B by C. Okay, so now we will go with the next one. So next is the A. So A is inserted here. Next plus is inserted here. So now the operator is available and operands are available. So again we will apply the same formula. That is, so you will get the answer as A plus B by C. Okay, so after evaluating this operation, so A plus B by C. Okay, so next one, the last one is the multiplication operator. Okay, so we will push it back into the stack. So now again apply the same formula. So it will become, the expression is A plus B by C into A by D minus L. So this is the final output. So this element, this expression will be popped out of the stack. So this is the prefix to infix conversion. Okay, So normally we will start from the left to right evaluation, but here in the infix to prefix conversion we are going to evaluate starting from right to left. So consider the parenthesis, close parenthesis as the open parenthesis here, and then insert the element. Okay, so now insert the next 6 is there, 6 minus 5, right, 5, and then open parenthesis as closed parenthesis. So now we will pop the minus element out of the stack. Okay, so then it will result like this, 6, 5 minus. Okay, so after popping it out, so we will get the empty stack again. So now we will go with the next one. Next one is the exponent operator. Okay, so next is the 4. Okay, so out of the 4, multiplication operator is there, but based on the priority, so here the multiplication is having lower priority than the exponentation operator. So that's why we are going to pop this element out of the stack. Okay, exponent is popped out of the stack. Okay, so next the multiplication operator is pushed into the stack. So next one is the, so we will consider closed parenthesis as open parenthesis here, and then 3 is inserted to the expression. Next plus, so we can place the low priority operator over the higher priority operator, that is the multiplication. Okay, sorry, we are placing the plus operator over the parenthesis, right? That's why the priority doesn't work here. So plus is pushed to the stack. Next one is the 2, and then close it parenthesis. Okay, so now the element plus will be popped out of the stack here. So plus is popped out of the stack. So after that one, so there is no operator to push into the stack. So the last one is the multiplication operator will be popped out of the stack. So this is the infix to prefix conversion. So next one is the evaluation of the prefix expression. So this is the given prefix expression. So we have to evaluate this given expression. So normally in the case of the infix expression, that means 2 into 3, that means it will give the value 6. But in this case of X type of expressions, then we cannot solve this directly, right? So for this we are going to use a stack to evaluate this prefix type of expressions. Okay, so you can directly also apply the we can directly solve this one. So here multiplication 2 3, right? So it will give the answer as 6. Okay, so next 6 plus 4. Okay, so 6 plus 4, it will result the value as 10. Okay, so now 10 minus 5, so 10 minus 5 is 5, so it will give the answer as 5. So this same thing we are going to implement it using the stack. Okay, so first of all, so note down the values here. So 2, so starting from the right to left, first insert the value 5 into the stack, then 4, next one is 3 and 2. Okay, so we have inserted the elements here. So now we will insert the operators into the stack. So first we will insert the multiplication operator. So when we insert the operator here, the expression will get evaluated. That is 2 into 3 is 6, right? So the answer is 6. So we'll take a new stack here with the 4, 5, 6. 2 into 3 is 6. So now the addition operator is inserted here. So now 6 plus 4 becomes 10, right? So 6 plus 4 value will become 10. So 10 will be inserted here. Okay, now minus is pushed to the stack. So 10 minus 5 is 5. So the final answer is 5. Okay, so this is the prefix expression evaluation. The next one is the postfix expression evaluation. So here we have taken a expression, we have to evaluate using the postfix expression notation. Okay, so we can directly solve this without using the stack also. Okay, so first one is the 2 into 3, that is 6, and 6 4 plus, that means 6 4 plus means 6 plus 4 is 10, so the answer will be 10. So the same thing we are going to apply it using the stack. So without precedence operator, priority can perform the evaluation. So here we are going to insert the values into the stack. Okay, starting from the left hand side. So 2 is inserted here, next 3, and then insert the multiplication operator. So 2 into 3 will become 6. Okay, so here the 6 will be there, and then next value is 4, and then plus. So now 6 plus 4 is 10, right? So 10 will be written here. So in this manner we can evaluate the postfix expression. So why we are going with the postfix and the prefix expression? Postfix and prefix expression instead of using the infix means. So if you are using the infix expression, then it will take a lot of time, because in the case of the infix expression evaluation only, we are following the operator precedence and associativity rules. Okay, so if you want to solve certain expression, it is 2 plus 3 by 5 minus 9. Okay, so if you are going to follow this infix notation, then you have to apply the operator precedence and associativity rules. Okay, but if you are using the prefix and postfix expressions, then there is no need of applying the precedence and associativity rules. Directly we can solve it using the stacks. Okay, so instead of applying the precedence and associativity rules from the infix notation, it will be easier and time saving to use the prefix and postfix expressions. Okay, so that's why we are using the prefix and postfix expression evaluation in the computers mostly. So this is about the expression evaluation and conversion using the stacks. Thanks for watching the video. Please do like, share and subscribe to my channel. Thank you.